The Leave plan of room specialists has found that, using our new 101 billion toy, it will be apparently perpetually before that try changes into a reality. On the remote possibility that it goes as planned, the excursion to Proxima B will expect near 20 years. So, sensibly it will be 2 or 3 years earlier before we can request whether there is certain life on that planet. The firmly established sales of whether we are really alone in this universe get through. The James Webb Telescope has discovered a few incredibly humanesque things far away from Earth that lead us nearer to the response. Our main goal for life beyond us has been uncontrolled throughout every human action, so much so that we have countless media works and speculations concerning this matter. Our wonder concerning our spot and hopelessness in the universe has been consistent. It is saturated inside us to reliably search for a mate, in spite of how halfway we might be. We might draw progressively nearer to the responses we really need. How, anyway, are they truly the answers we are looking for, or are they essentially seriously upsetting? Join us as we examine the latest discovery in the space of systems and planets on the journey to find something we probably won't be prepared to see. Lights far away. Informed authorities have found what could be the most significant discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, an extremely interesting hypothetical question was raised about the capabilities of our technology. The inquiry was whether later on our telescopes could distinguish artificial light on another planet, for instance, Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was recognized to be perfectly locked with a very long-lasting day-side and night-side, like our Moon. A hypothetical imaginative enhancement for Proxima B could move power and energy from the day-side to the night-side, utilizing photovoltaic cells that make power from starlight. Subsequently, in a paper with Mana Ling as one of the researchers, it was shown that a gigantic concentration of the day-side by solar chargers could be associated with future telescopes. Since JWST was also developed, it would allow us to expand our quest for artificial lights on exoplanets like Proxima B. Now, the truth that the James Webb Space Telescope did precisely that in 2024, using its higher sensitivity and greater degree of capabilities, is pivotal. The JWST might have found the lights we were searching for, and maybe flung us into another huge surge of human action. Overall, we should jump into the universe of planets and exoplanets to figure out how this was without a doubt even possible. James Webb's mission explores Proxima B and Proxima B's secrets. Beginning from the start of written history, people have contemplated the chance of the universe, what we are, where we come from, and where we go. These are traditional yet surprisingly irksome solicitations that humanity has attempted to answer. When we acquired awareness in the time of phenomenal mechanical improvement, one wonders whether we are any closer to answering these requests. If you somehow happen to ask a logician, he could say we are currently at level 0 of understanding ourselves in the universe. At any rate, ask a space expert the same question, and watch him make the most of his energy as he competitions to tell you the latest discovery individuals have made about the universe using their clever gadgets. These instruments, though not really thought about by the general public, are directly an impression of human action itself. We now have the world readily open, and it's time we push forward and get the universe readily available too. One such strategy for doing so was determined by scientists and space experts through the innovation we tackle. A specific creation of that innovation is now liable for the new discovery of what might be light on another planet light-years away. Yes, we're examining the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the traditions of human endeavors into space to address some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science gadget has already begun keeping an eye out for these sales. Despite the reality that at first you might find yourself asking, what is Proxima B? Proxima Centauri B, or just Proxima B, is sometimes alluded to as Alpha Centauri C. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could perplex you, but don't worry. This message will settle all your burning questions. Super-Earths are a class of planets that are more enormous than Earth but lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made of gas, rock, or even a blend of both, and their sizes can differ from 2 times the size of Earth to several times its mass. In regards to Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planet group. The first possible proof of an exoplanet was seen in 1917, although it generated little interest. However, confirmation came in 1992 with the first confirmed discovery, which left scientists shocked. Another exoplanet, first recognized in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These famous discoveries are surrounding an M-type star. To understand the M-type star, you need to figure out the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the interconnecting district of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have staggeringly low luminosity, and since glow is one of our primary tools for planet location, red dwarfs are not so easy to see. These unnoticeable stars have variable definitions and names, depending upon their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, hence getting their name. Also, in regards to Proxima B, its mass is known to be equivalent to 1.07 Earths. Inquisitively, it only requires 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can check the size of the star Proxima B is orbiting. Unbelievably, under the assessment of the entire electromagnetic spectrum, the star has a total luminosity of as little as around 1.6% that of the Sun. Other than in the visible light range, its radiance seems to decrease more. It only shines 5 to 6% of the Sun's luminosity, emitting a much lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is infrared radiation, surrounding around 0.045 to 0.056 galactic units from its star. Proxima B's discovery was reported back in 2016. You could ask why Proxima B, with a million stars, planets, and galaxies, is of such focus. Well, there are several reasons that contribute to the noticeable interest cosmologists have here. Specifically, Proxima B is the nearest known star to our Sun, and by definition, albeit 4.2 light-years is a major number to us Earthlings in the fabulous plan of the universe, it is a straightforward blip. Consequently, why is Proxima B, our closest realized star, high up on the need list right now? It is important for the triple star framework called Alpha Centauri. Additionally, in spite of Proxima's glow being unquestionably low, the actual framework appears as quite possibly one of the most brilliant heavenly bodies in the night sky, behind two others called Sirius and Corvus. Anyway, the most enchanting thing about Proxima Centauri B is that it could truly be livable, as it falls inside the habitable zone. The potential outcomes surrounding the star are ceaseless, and subsequently, cosmologists have assumed the task of investigating the depths and limits of the star's actual potential. That is where the James Webb Space Telescope comes in. The four crucial targets of the JWST are to search for light from the primary stars and universes that formed in the universe after the Big Bang, concentrate on the universe's arrangement and development, sort out star and planet formation, and spotlight on planetary frameworks and the starting points of life. As the JWST continues its assessment of the said exoplanet, we draw nearer to the culmination of these missions, from searching for exoplanets to looking for extraterrestrial life. So what precisely is SCI? One could ask, considering that people have forever been an inquisitive species, reviewing and getting into literally all that moves and doesn't move. It checks out that a mission like SCI appeared on such a colossal scale. Imagine that God has facilitated a fantastic, enormous endeavor, but with a hint of gold. We are endowed with being on the lookout for signals. More specifically, electromagnetic murmurs from human civilizations past whatever we might ever imagine. SEI, short for the search for extraterrestrial intelligence, looks like the world's most high-stakes game of hide-and-seek, with our team as the searchers and the immense universe as the seemingly eternal hiding spot. It is one of those fields where specialists resemble advanced Sherlocks, tuned into radio waves and scouring for that unobtrusive, we are not alone signal. This grandiose sneaking around started during the 1960s. Frank Drake, a striking astrophysicist, was among the first to identify radio transmissions from the stars. It was a critical moment, but no outsiders appeared at his door, at least not yet. As you might have speculated, searching for something this huge takes patience and can span numerous years of work. Sometimes, not many conclusive extraterrestrial transmissions have been found in spite of these efforts. The energy continues to grow as the James Webb Space Telescope inspects exoplanets like Proxima B. An entire field of hope is emerging. However, will we coincidentally find genuine proof of extraterrestrial life, or will we just experience creepy transmissions right outside our capacity to fathom, giving us more questions than answers? The discovery of lights, in fact, could mark the next chapter of humanity's eternal curiosity, where inquiry and progress blur into one enormous, exciting space story. So, let's keep looking, hoping to find confirmation that we are not truly alone. The discovery of lights from faraway exoplanets, like those potentially seen on Proxima B, could be a monumental step toward answering one of humanity's most significant questions. Are we alone in the universe? As the Webb Space Telescope continues to examine the skies, its discoveries will undoubtedly spark more conversations, examinations, and perhaps challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of these revelations reach far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific systems. For instance, if we were to confirm that Proxima B, or another exoplanet, harbors some type of life, it would require us to reconsider our place in the universe. Could life elsewhere develop in ways similar to our own, or would it present a totally new kind of existence? Would it follow the same evolutionary paths, or would its science and consciousness challenge everything we know about life on Earth? Regardless of whether we find direct proof of intelligent life, the simple fact that we could detect artificial transmissions or lights from far-off worlds would still have significant implications. It would mean that there are intelligent civilizations out there, at least hypothetically capable of adapting their surroundings in ways that become perceptible from our vantage point. This would confirm that intelligent life is not a rare anomaly but maybe a widespread outcome of specific conditions in the universe. In any case, it's essential to remain grounded and cautious in the face of such discoveries. While the potential for finding life is exhilarating, it also raises the question: what happens next? How might we respond to the confirmation of extraterrestrial life? Would we approach it with respect, interest, and scientific caution, or would the revelation spark frenzy, fear, or even political battles? History has shown that humanity's reactions to new discoveries, especially those that challenge deeply held beliefs, can be erratic. We must also consider the ethical aspects of our curiosity. If we do find evidence of life, particularly intelligent life, what does it mean for our responsibilities as stewards of our own planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely be a central part of the conversation as we venture further into the universe. In any case, the search for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents an intriguing convergence of science, philosophy, and humanity's future. The next few years will likely be filled with more discoveries, more questions, and perhaps even answers that challenge everything we thought we knew about the universe and our place within it. The story of our quest for extraterrestrial life is, in a sense, just beginning. With each new development, we draw closer to a moment that could change the course of humanity's history forever. As we continue to probe the mysteries of the universe, the search for extraterrestrial life intensifies, and new discoveries challenge the way we understand our place in the universe. The role of space exploration, particularly with groundbreaking technologies like the James Webb Space Telescope, JWST, has revolutionized our ability to detect distant worlds and potentially trace signs of life beyond our planet. However, this journey is not without its complexities. As we extend our observational capabilities, we also face new philosophical and moral dilemmas that could reshape human civilization. With Proxima B being a close neighbor to Earth in cosmic terms, its study offers an exciting window into the future of astrobiology. However, while the possibility of finding life on exoplanets is captivating, it's essential to approach this journey with caution. The nature of extraterrestrial life, if it exists, may be drastically different from what we expect. Life may not necessarily conform to Earth-based, perhaps it exists in forms so foreign that we struggle to recognize it, or maybe it operates under conditions we can't yet comprehend. The potential discovery of artificial light or technological signals from distant exoplanets also raises significant questions. Such findings would suggest that we are not alone in the universe and that intelligent life may have evolved elsewhere, developing technologies that reflect or even surpass our own. This realization would force humanity to reconsider its assumptions about intelligence, technology, and the possibility of interstellar communication. But with these discoveries also come concerns about how we would communicate with such beings, assuming they exist. The implications are profound, touching on everything from international cooperation in space exploration to the potential for future interstellar diplomacy. The discovery of extraterrestrial life could challenge the very foundations of science, philosophy, and religion, forcing humanity to reconsider its self-awareness and purpose in the grand scheme of the universe. In this light, the search for life beyond Earth is not just about science. It's a journey that could ultimately alter the trajectory of humanity's existence. As humanity progresses in its exploration of the universe, our technological capabilities are expanding, allowing us to venture deeper into the unknown. With missions aimed at finding life on distant planets, the prospect of extraterrestrial civilizations becoming a reality grows ever more possible. These discoveries are not just scientific achievements, they are cultural milestones that could redefine our collective identity. While the quest for knowledge about the universe continues, it also ignites important debates about the future of humanity. Will we act responsibly in our exploration, ensuring that we preserve the integrity of other worlds, or will our curiosity push boundaries too far?